Morning students, I am Mrs. Shravanti Jagdish Vanga, working as an assistant professor in the Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. In this session, we are going to learn about indeterminate forms. Learning outcomes. At the end of this session, students will be able to solve the problems of indeterminate forms. Basically, first we will understand the terminology of indeterminate forms. In calculus and other branches of the mathematical analysis, limits involving an algebraic independent variable may often be evaluated by replacing these functions by their limits. If the expressions obtained after this substitution does not give enough information to determine the original limit, it is said to be an indeterminate form. There are 7 types of indeterminate forms. Let us see. The first form is 0 by 0. Second form is infinity by infinity. Third form is 0 into infinity. Fifth one is infinity minus infinity. 0 into infinity. Sixth type is 1 to the power infinity. Seventh one is infinity to the power 0. These all are some indeterminate forms. Now, in this particular class, we are going to learn how to evaluate the indeterminate forms and find the limits. Before that, it is really very important to learn the L'Hospital rule to evaluate the indeterminate forms. Basically, this L'Hospital rule is a general method for evaluating the indeterminate form 0 by 0 and infinity by infinity. And this rule states that limit x tends to a f of x upon g of x is equals to limit x tends to a f dash of x upon g dash of x. If limit x tends to a f of x is equal to f of a, and which gives you the limit as infinity or 0, and limit x tends to a g of x which is equal to g of a, which gives you the limit infinity as or 0, where these functions f dash of x and g dash of x are the derivatives of f of x and g of x. Means whenever you find the indeterminate form, you need to just differentiate the numerator and the denominator separately to find the limit. We'll see type 4 problems, that is infinity minus infinity forms. Let us see the definition of this form. Limit of the form, that is limit x tends to a f of x is equal to infinity and limit x tends to a g of x is equal to infinity. Now these types of indeterminate forms are called as the infinity minus infinity forms. If we write limit x tends to infinity f of x minus g of x as limit x tends to infinity 1 upon g of x minus 1 upon f of x upon 1 upon f of x into g of x, then the limit become of the form 0 by 0. Means whenever you see the indeterminate form of infinity minus infinity type, you need to use some algebra to express that infinity minus infinity type in terms of 0 by 0 form. And this can be evaluated by using L'Hospital rule. Let us revise the rules to evaluate the form 0 by 0. First, we need to check whether the limit is an indeterminate form. If it is not, we cannot apply L'Hospital rule. In the next step, you need to differentiate f of x and g of x separately. After that, substitute the limit. Check if g dash of x is non-zero term, that is, substitute the limit if g dash of a is not equal to 0, then the limit will exist and it may be finite plus infinity or minus infinity. But if you are getting g dash of a as a 0 term, then again you need to repeat the procedure. That is, again differentiate f dash of x and g dash of x separately. And we are going to continue this process till the required value is reached. Now let us see one example of infinity minus infinity form. Evaluate limit x tends to 1, 1 upon log x minus 1 upon x minus 1. Now in this example, if you directly substitute the limit, you are getting infinity minus infinity if we try to evaluate directly. So we need to start by using algebra, that is putting the expression over a common denominator which will gives you the form 0 by 0, and later it can be solved by using L'Hospital rule as follows. Now here limit x tends to 1, 1 upon log x minus 1 upon x minus 1. I am writing this as limit x tends to 1, x minus 1 minus log x upon x minus 1 into log x. I have just cross multiplied. Now substitute the limit. X tends to 1 means 1 minus 1 you are getting at 0. Log 1 is 0. 1 minus 1 0. Log 1 is 0, which is nothing but 0 by 0 form. Now, once you get the 0 by 0 form, you can apply the L'Hospital rule. Applying L'Hospital rule means differentiating numerator and a denominator separately. Therefore, limit x tends to 1. Now, differentiation of the numerator. X minus 1 derivative is 1 minus log x derivative is 1 by x. Denominator's derivative. In the denominator, there is a product of two functions, x minus 1 into log x. So here, while differentiating, I need to use u dot v rule of the differentiation. So, log x as it is, differentiation of x minus 1, that is 1, plus x minus 1 as it is, derivative of log x, that is 1 by x. Now simplify this term. You will be getting limit x tends to 1, x minus 1 upon x into log x plus x minus 1. Now substitute the limit. What you are getting? This 1 minus 1 will be 0. Again 1 into log 1, again 0, plus 1 minus 1 is 0. Again you are getting this as 0 by 0 form. Means here g dash of a is 0. So again you need to differentiate this f dash of x and g dash of x separately. Now again applying L'Hospital rule. Limit x tends to 1, 1 upon log x minus 1 upon x minus 1. I have applied again L'Hospital rule. Numerator's differentiation, x minus 1's differentiation is 1. In the denominator you are having x log x function. So again using u dot v rule, you are getting the differentiation as x into log x derivative is 1 by x plus log x as it is, derivative of x is 1 plus 1. now simplifying this, you are getting as 1 upon 1 plus log x plus 1. Now put the limit 1 upon 1 plus log 1 plus 1. Log 1 is 0, hence I am getting the limit as 1 by 2. So limit x tends to 1, 1 upon log x minus 1 upon x minus 1 is equals to 1 by 2. I hope you have understood the procedure. Now we'll see the next example for more clarification. Here, example is the limit x tends to 0, 1 upon x square minus cos x upon x square. Again, put the limit directly. So, if you substitute the limit directly, 1 upon 0 you are getting as infinity minus cos 0 is 1 upon 0 is infinity. Means infinity minus infinity form. So this example has the form infinity minus infinity if we try to evaluate directly. So we need to again start by using some algebra, that is putting the expression over a common denominator, which will gives you the form 0 by 0, and later it can be solved by using the L'Hospital rule as follows. Simplify this. Limit x tends to 0, 1 upon x square minus cos x upon x square can also be written as limit x tends to 0, 1 minus cos x upon x square. Now if you substitute the limit x tends to 0, here 1 minus cos 0 is 1, 1 minus 1, 0. If you substitute x as 0, denominator is 0. Hence, you are getting here as 0 by 0 form, which is indeterminate form. Now you can apply the L'Hospital rule. Applying L'Hospital rule means differentiating numerator and denominator separately. Now, differentiation of a numerator. Limit x tends to 0 as it is. Derivative of 1, 0, minus cos x derivative is minus sin x. Now, denominator's derivative, x square derivative is 2x. Simplify this. So, I am getting this as limit x tends to 0, sin x upon 2x. Rearrange the terms in a such a way that 1 by 2 into limit x tends to 0 sin x upon x. And you know that limit x tends to 0 sin x upon x is always 1. Therefore, 1 by 2, this quantity value is 1. Hence, I get limit x tends to 0, 1 upon x square minus cos x upon x square is equal to 1 by 2. References: Engineering Mathematics by Ravish R. Singh and Mukul Bhatt. Thank you.